Uranus heat mystery solved. Why it's hotter than it should be. It's official. Uranus is indeed hotter than one might expect it to be. Despite its chilly reputation, this distant planet emits more internal heat than it absorbs from the Sun, a fact that has puzzled scientists for decades. Recent studies, drawing from years of observations, have confirmed that Uranus radiates approximately 12.5% more heat than it receives from solar rays. This revelation comes from two independent research teams, finally solving a mystery that began when Voyager 2 flew by Uranus in 1986. At that time, data suggested that Uranus was not releasing any excess heat, which contradicted the behavior of other gas giants in our solar system. Xinyu Wang, a planetary scientist now at the University of Michigan, led one of the teams that made this significant discovery. Wang's research indicates that Uranus is still gradually losing heat from its formative years, providing crucial insights into the planet's history and evolution. This finding is essential for understanding not just Uranus, but also other giant planets in our solar system, Wang explains. He believes this strengthens the argument for future missions to explore Uranus further. Interestingly, previous studies have shown that the conditions during Voyager 2's flyby were influenced by heightened solar activity, which may have skewed the data collected at that time. This context helps explain why earlier readings might not accurately reflect Uranus's typical state. However, the new findings raise further questions about the planet's internal dynamics. For comparison, Jupiter emits 113% more heat than it receives, Saturn 139%, and Neptune, despite being farther from the Sun, emits a staggering 162% more. This discrepancy suggests that Uranus has some unique internal characteristics or a distinct evolutionary path that sets it apart from its neighbors. The researchers emphasize the importance of investigating the outer planets of our solar system, which are often overlooked. They advocate for a flagship mission to Uranus, which could yield vital data to answer many unresolved questions about this intriguing ice giant. This groundbreaking research has been published in the journal Geophysical Research Letters, marking a significant step forward in our understanding of Uranus and its mysteries. What do you think about these findings? Do you believe we should prioritize missions to Uranus, or are there other celestial bodies that deserve our attention first? Share your thoughts in the comment. NASA and Oxford reveal Uranus may be warmer than thought. Get ready for a mind-bending revelation about one of our solar system's most mysterious planet. Uranus, the ringed, blue world, has been keeping secrets from astronomers for centuries. But recent NASA research has uncovered a surprising truth: Uranus is warmer than we once thought. You see, Uranus is a unique character in our cosmic neighborhood. It spins on its side, giving each pole a continuous 42-year summer. And it rotates in the opposite direction to most planets, except Venus. This quirky behavior has always intrigued scientists, but it's the planet's internal temperature that has been the real head-scratcher. For a long time, data from NASA's Voyager 2 flyby in 1986 suggested that Uranus was unusually cold inside. This challenged our fundamental understanding of how planets form and evolve. Amy Simon, a planetary scientist at NASA's Goddard Space Flight Center, put it this way: since Voyager 2's flyby, everybody has said Uranus has no internal heat. But it's been really hard to explain why that is, especially when compared with the other giant planets. But here's where it gets controversial. Simon and her team, led by Patrick Irwin from the University of Oxford, decided to revisit this mystery. Using advanced computer modeling and a fresh look at old data, they discovered that Uranus does, in fact, generate some heat. Their findings were published in the monthly notices of the Royal Astronomical Society. A planet's internal heat is calculated by comparing the energy it receives from the Sun to the energy it releases into space as reflected light and emitted heat. The other giant planets in our solar system, Saturn, Jupiter, and Neptune, emit more heat than they receive, indicating that they have warm interiors. Uranus, however, appeared to be an outlier, giving off as much heat as it received, which implied it had no internal heat source. This led to some wild theories. Some scientists hypothesized that Uranus might be much older than the other planets and has simply cooled down over time. Others suggested that a massive collision, possibly the same one that knocked Uranus on its side, could have blasted away all its internal heat. But these hypotheses didn't quite add up, leaving scientists eager to solve this cosmic cold case. Irwin and his team realized that the key to understanding Uranus' heat was in its reflectivity. They calculated that Uranus is more reflective than previously estimated, meaning it reflects more sunlight back into space. This new understanding of Uranus' reflectivity changed the calculations of its energy budget. Using a computer model that incorporated decades of observations from ground and space-based telescopes, including NASA's Hubble Space Telescope and the Infrared Telescope facility in Hawaii, the researchers found that Uranus releases about 15% more energy than it receives from the Sun. This suggests that Uranus does have its own internal heat, although it's still much cooler than its neighbor Neptune, which emits more than twice the energy it receives. So, what does this mean for our understanding of the universe? Well, unraveling Uranus' past is not just about satisfying our cosmic curiosity. It helps us piece together the timeline of when solar system planets formed and migrated to their current orbits. And it also provides valuable insights into the many exoplanets, planets outside our solar system that we're discovering, most of which are similar in size to Uranus. As Simon said, now we have to understand what that remnant amount of heat at Uranus means, as well as get better measurements of it. So, there's still much to uncover about this enigmatic planet. But one thing's for sure, Uranus is not as cold and distant as we once thought. It's a warm, reflective world with its own unique story to tell. And that, my friends, is the part most people miss about Uranus. Uranus, the surprising heat mystery unveiled. Wow, the seventh planet may be hiding a warm secret after all, and this is the part most people miss. For nearly 4 decades, Uranus was dismissed as a cold case, a world that seemingly lacked any internal furnace. But fresh analyses tell a warmer, far more intriguing story. Uranus, famous for rolling around the Sun on its side, basks each pole in an unbroken 42-year summer and spins in the opposite direction of every planet except Venus. Yet, until now, scientists believed it radiated almost exactly the same amount of energy as it absorbed, implying a frigid interior. That conclusion rested on a single Voyager 2 snapshot taken during its 1986 flyby, a lonely data point that shaped textbooks for generations. But here's where it gets controversial. 2 independent research teams have just pored over decades of telescope records and crunched the numbers with state-of-the-art computer models. Their verdict? Uranus actually emits roughly 15% more energy than it receives from the Sun. How did they rewrite the narrative? 1. A hard look at reflectivity. Patrick Irwin of the University of Oxford and his colleagues realized Uranus reflects more sunlight. Technically, it has a higher bolometric bond albedo than once thought. If the planet bounces away extra sunshine, yet the total outgoing energy hasn't changed, something inside must be adding heat. 2. A planet-wide energy audit. To balance the books, researchers simulated Uranus's atmosphere, folding in hazes, clouds, and seasonal effects gleaned from Hubble, ground-based observatories, and even the Infrared Telescope facility in Hawaii. The model compared incoming solar energy, light scattered in every direction, and heat bleeding into space. 3. A second opinion. A companion study, published in Geophysical Research Letters, arrived at virtually the same 15% excess, solidifying the claim that Uranus does, in fact, possess its own heat source, albeit weaker than Neptune's, which gushes out more than double what it takes in. Why does internal heat matter? Giant planets behave like cosmic thermometers. The more heat they still shed, the younger, or the better insulated, they may be. If Uranus is cooler than its neighbors, is it truly older, or did a colossal collision, the same one that probably tipped it over, strip away much of its primordial warmth? The debate is far from settled, and these new results only deepen the mystery. Key voices in the investigation. Dr. Amy Simon, NASA Goddard. Everybody has said Uranus has no internal heat. Everything hinged on that one data point. That is part of the problem. Professor Patrick Irwin, University of Oxford. We asked, could it really be that there is no internal heat at Uranus? Our recalculations show otherwise. Quick refresher for beginners. Internal heat is gauged by subtracting reflected sunlight from total outgoing energy. Any excess must leak from the planet's interior, left over from its violent birth 4.5 billion years ago or generated by still poorly understood processes. So, what's next? Scientists now want finer measurements, possibly from a future dedicated mission, to pin down exactly where Uranus's modest warmth originates and why it differs so dramatically from Neptune's. Instruments that can map heat in multiple wavelengths and probe deep beneath the hazy clouds will be crucial. Bold question that could split opinions. If a single flyby misled us for decades, should we reconsider other settled facts in planetary science? Could more distant worlds be hiding surprises under the veil of limited data? Your turn. Do these findings overturn what you learned in school, or do you remain skeptical until a new spacecraft pays Uranus another visit? Share your take. Is the ice giant secretly hot stuff, or are we still